Welcome once again. So, in this problem, the second problem, we will solve a problem involving the absence of U. In this problem, U is not given. So, let us see how we can solve this problem. Steam flows through the nozzle with a velocity of 450 meter per second at a direction which is inclined at an angle of 16 degree to the wheel tangent. That is, V1 is given to be 450 meter per second and alpha 1 is given to be 16 degree. He also mentions steam comes out of the moving blades with a velocity of 100 meter per second. That is, exit velocity of steam is V2 is mentioned to be 100 meter per second in the direction of, this is important, 110 degree with the direction of blade motion. With the direction of blade motion, it is making an angle 110 degree. The blades are equiangular, that is beta 1 is equal to beta 2, and also he mentions steam flow rate is 10 kg per second. As usual, he is asking power developed, axial thrust, blade efficiency, blade coefficient. We have calculated these already in the last problem. The only new thing here is the power loss due to friction, right? So, we know power loss due to friction occurs because of the reduction in the relative velocity. We shall calculate the change in relative velocity and the energy loss accustomed to it. So this is quite simple, but the only thing here is the absence of U. So let us see how we shall deal with that. Now, according to the given velocities, let us choose a scale. Here I have chosen 1 centimeter is equal to 50 meter per second. And now let us start from, as usual, from U. So let me draw a line of some length, since I do not know the exact length. So let me draw U of some length and let this be the point A be the starting point of it. So what do I do now? I already have alpha 1 and V1 known to me. So let me draw V1 at an angle alpha 1. That is, so according to the given scale, V1 becomes 450 meter per second, that it becomes 9 centimeter. So let me draw an arc of 9 centimeter first, right? And also let me cut it for angle 16 degree. So 16 degree will be somewhere here. So let me mark that and let me draw V1. That is from this point along this angle 16 degree. Let me draw till here. This is my point C. I still do not know point B because I do not know where to join point C to point B because I do not know what is the exact velocity of U, right? So now in this problem, along with V1, V2 is also given and alpha 2 is also given. Alpha 1 is calculated to be 110 degrees Celsius, 16 degrees Celsius, right? That is what we drew just now. Now, V2 is also given from the same point V2 goes at an angle alpha 2. V2 is given to be 100 meter per second. So 100 meter per second means it becomes a 2 centimeter line at an angle 110 degrees Celsius with the direction of the blade motion. So if this is the direction of blade motion, so alpha 2 is 110 degree with respect to this line. So let me mark 110 degree first, that is 90, 100 and 110, right? So in this direction, let me draw a 2 centimeter line. So that is from 6 to 4. This is the 2 centimeter line that I need to draw, right? So this angle is given to be 110 degree and therefore this angle alpha 2 is 70 degree, right? So V2 makes an angle alpha 2. So this is, let me write clearly, this is V1, This is V2 at an angle alpha 2, isn't it? Now, since we know V1 and alpha 1, let me draw VF2. VF2 I can easily draw because all I have to do is portray axially downwards. So VF2 will be like this. Sorry, VF1 will be like that. VF2 will be axially downwards, right? This is VF2. Now, there is no way I can calculate the length of U. So what do? I will use a trick here. Now, I will measure the length of VF2, which is 2 centimeter, and I will mirror it down. So that means I will draw the same 2 centimeter downwards. That is, right? Then what I will do? I will cut it. Here what I have done? I have taken the length of VF2 and I have mirrored it downwards. The same length I have drawn in the below section. Now what do? I will join point C and this point F. Okay. So that the line where point C and F joining cuts this line becomes the U. Thereby I can measure U. That is, here to here, if I can join, it cuts somewhere along here. So this point is my point B. Now I have found the B. Let me measure that. If I can measure AB, which is found to be 3.2 centimeter. So when I say 3.2 centimeter, I will write. So always make a habit of writing the lengths and velocities just beside the velocity diagram generally. Okay. That is, here V1 is at an angle alpha 1, so that is V1 is of some length, that is 9 centimeter. That is why the velocity 450 meter per second, right? Then VR1, then VF1, then V2, VR2, VF2 and U. Okay, always make a habit of writing the lengths and the velocities so that you will have a better understanding. Now the line joining point D and point B becomes my VR2, that is, this line is the VR2. Let me draw that and measure that. That is, VR2 is of length 4.7 centimeter. So 4.7 centimeter. So now I have drawn all the velocities here. I have measured them also. Let me convert them. VR1 is 5.6, that is 5.6 into 50, 280 meter per second. Then 2.7, that is 135 meter per second. This is 2, already given 100 meter per second. VR2 is 4.7, that is 235 meter per second. Then VF2 is 2 centimeter, that is 100 meter per second. And U is 3.2, that is 160 meter per second. Now we were not knowing U at the starting of the problem. Now we found U, that is 160 meter per second. And this completes our construction of the whole triangle, right? So now using all these values, if I can, now I have to measure beta 1 and beta 2 also. Then thus that complete my triangle construction. Then I can easily go for the calculation of the asked values, right? So I have to measure beta 1 and beta 2, that is the radial distance. This distance is my delta VU, right? And also this distance, the distance between the tips, is my delta VF, right? So that I have to measure again. So all these parameters I have to measure and calculate, right? Now I have measured delta VU, delta VF also. So those are 9.4 centimeter and 0.6 centimeter, which upon conversion becomes 470 centimeter per second and 30 meter per second. Now let us move towards the calculation of the parameters that are being asked. The first thing they are asking is the power developed wait a second, here power developed P is equal to, we already know this, M by Gc into U into delta VU, which is the work done. So therefore I shall write mass flow rate is given to be 10 kg per second divided by 1000 into U is 160, which is found to be 160 using the triangle which is drawn by us, and also into 470 meter per second delta VU. So upon calculation, power becomes 780 kilowatt approximately. So this is the, again this is the beauty with the graphical method, where we will get the values directly. The second thing being asked here is power loss due to friction. Power loss due to friction, that is the frictional loss pertaining to CB. Okay. So this power loss due to friction can be calculated as M by Gc into delta HF, which is M by Gc into 1 by 2 Gc into VR1 square minus VR2 square, right? So if I can calculate that, we know that already. So this becomes 10 divided by 1000 into 1 by 2 into VR1 square, which is VR1 is found to be 280 square minus VR2 is 235 square, right? So this becomes, power loss due to friction becomes 182 kilowatt. Here frictional loss is considered between the variation of relative velocities. The third thing that is being asked in this problem is axial thrust. We already know how to calculate axial thrust, that is F axial is equal to M by Gc into delta Vf, right? Delta Vf we have found graphically directly, that is M is 10 divided by Gc 1000 into the delta Vf, which is 30 meter per second. So 30 into 300. So this is 0.3 kilonewton. Axial thrust is found to be 0.3 kilonewton. Then the fourth parameter is rotor efficiency. Rotor efficiency or the blade efficiency. Both are one and the same. So epsilon blade is eta blade is equal to 2 into U into delta VU divided by V1 square, right? So 2 into U is found to be 160 into delta VU is found to be 470, right? Divided by V1 square. V1 is 450 meter per second, so 450 squared. So this becomes 77%. So this is the blade efficiency, right? The last thing they are asking us is the blade coefficient. So in the last problem, blade coefficient was directly mentioned. Here they are asking us to find blade coefficient. We already know blade coefficient is nothing but CB, which is the ratio of VR2 divided by VR1, right? So that is VR2 is found to be 235 divided by 280, right? So this is found to be 0.76, that is 76%. So CB is found to be 0.76. This is the problem.